postulates and diagrams, we're going to ask ourselves the following question. In a diagram, like we just looked at, what can be, oh, what's the word? What can be assumed and what can be labeled, okay? Did we just say that assuming stuff is good or assuming stuff is kind of bad? Kind of bad, isn't it? Okay, it's kind of bad. So in order to be able to answer that question, guys, in a diagram, what can be assumed and what can be labeled, we're going to have to make sure we understand how to identify postulates using diagrams, and then we're going to go ahead and work on sketching and interpreting diagrams. Okay? Vocab's not too important today. The vocab is kind of one of those deals when we talk about planes and lines. You guys remember way back at the beginning of chapter 8 we talked about planes and lines passing through a plane? Okay, so what we're getting at in that first one right there where it says line perpendicular to a plane, it would mean that if I'm holding this piece of paper flat, that a line comes from the floor straight up through it. It doesn't come in through it at an angle, but it goes straight through it and then straight up. Okay, so all the angles that are formed with the plane and the line are going to be 90-degree angles. Okay, so the line's not going through it at an angle, the line's going to pass through your paper at what angle? 90 degrees, okay? So maybe the best way to maybe sketch this would be the following. Maybe you guys draw this for me. You know, draw a plane first. So I'll just draw my plane. Here's your plane right here. Whoops, there it is. There's your plane right there. And then basically, guys, the line that passes through that, is just going to be a line so that it maybe hits this point right here, and as it passes through it and then goes through the bottom side like this, I won't show the middle part of this, but as it passes through the bottom side here like that, between the plane and the line, what angle is going to be formed here, guys? What angles form between the line and the plane that it's passing through? 90-degree angle, so it's passing straight through it, all right? So a line perpendicular to a plane is basically a line going straight through a flat surface. It's perpendicular to the surface. Okay, so it'd be like drilling a hole. When you drill holes in walls, do you want to drill at an angle or do you typically want to drill straight through it? Okay. Well, I would say drill straight through it to put some nails and stuff in there or anything. Okay, if you're building stuff and want to put stuff in the wall, typically drill straight through. Does that happen all the time? No. This guy, no way. All right. All right, let's start talking about some postulates. I'm going to tell you this right now. These table of postulates right here, very, very important today. Very important stuff today. So you might want to star them, highlight them. I'm going to put a lot of drawings on this. Now here's the thing I want you to understand. We've talked an awful lot about conditional statements. If something, then something. So if I say, if you have a car, then you have how many tires? Hopefully.
4.
If you have a car, then you have 4 tires. Okay. The part that you're going to assume, let's just forget spares for now. The part you're going to assume is this. All right, let's just say, if you have a car, then you have an engine. Is that okay? The part you have to assume that you have is when I say the part right after if. So I say, if you have a car, you're thinking, okay, I have a car. So what's that mean? What else do I have? If I have a car, what could you put after then? Then you have what?
4 wheels.
4 wheels. Or if you have a car, you can say, then you have an engine. Or you can say, if you have a car, then you probably have problems. Right? Right? Okay? But you might just say, the idea is that if I say if something, that's saying, okay, this is what we've got. So what else does that mean that we have? So in this first postulate right here, a 2-point postulate, it says through any 2 points, there exists exactly what? 1 line. Okay? So I'm going to kind of write these up today as follows. I'm going to kind of divide this right through here. You might want to do the same exact thing. You might want to do the same exact thing. Divide that up. I'm going to kind of put the word if right here. This is what you have. This is what you're starting with. Then this is what the postulate tells you. Okay? So the 2-point postulate, the first one that we're talking about, this 2-point postulate says through, that should say and, this should be the word any. This should be the word any up here. Through any 2 points, there exists exactly one line. They're saying, hey, if I give you two what? If I give you 2 points right here, say a point here and a point here, and we call that point A, and call this point B. If I give you 2 distinct points, then those 2 distinct points determine a line through A and through B. So if you have 2 different points, can they go anywhere? Well, they have to be connected in that line. I'm saying if you have 2 points, A and B, then you also have a line A to B, okay? If you have 2 points, then you have a line, all right? So that's the 2-point postulate. What do you have? 2 points. So if I say you have 2 points, what else do you have then? You have a line. I say, hey, there's 2 points. So automatically you know you have a line. That's a rule. Okay, now the other postulate that's kind of in that box with yours is called the line point postulate, which is kind of the opposite of this, or switching it around. I said at the beginning for that first one, 2-point postulate said, hey, you have 2 points. Automatically you have what then? You have 2 points, automatically you have then a line. What if I switch that around? I say, if you have a line, then you automatically have 2 points. That's what this other one is, line point postulate. It's just the opposite of the 2-point postulate. It's saying, hey, here's a line. We'll call this line maybe, I don't know. Oh, there it is. We'll call this line XY maybe. So if I have that line x to y by these 2 points right here, this is not drawing very well. I need to calibrate. Give me a second, kids. Oops. Okay, we're saying if I have a line xy right here, then you have 2 points, x and y. All right? So those 2 postulates right here. If you have 2 points, what do you have then? A line. If I switch it around, if you have a line, then you know you have 2 points. Okay? So the 2-point postulate and then the line point postulate, just kind of opposites of each other. Okay? Next one's pretty easy. It's called line intersection postulate. If I say 2 lines intersect, where do 2 lines intersect at? Where do 2 lines cross at? Where? Where do they meet at? What's it called? It's called a point. You bet. If I have 2 lines that cross, like this line and this line, then that line, I don't know. I don't care what you name them. I might say this line and this line then cross at, how about we call this point P right there. So all that's saying is if 2 lines meet, they meet at a what? Point. Okay? Unlike parallel lines. Parallel lines have so much in common. It's a shame they'll never meet. You like that? I liked it. I thought it was good. Okay, I'm going to divide this one up then, guys. This is kind of a spin-off of each other. Okay? The first one's called the 3-point postulate. 3-point postulate says this: through any 3, and here's the big word, non-collinear, means they're not in a line. If you have 3 points that are non-collinear, there exists exactly what? One plane. So it's saying if you have the points like this, maybe A, B, and C like this, if you have 3 points that are not collinear, are those 3 points in a line or not? No. Then those 3 points will determine a flat surface. So these 3 points right here then would make up the plane. Here are your points again, A, B, and C. They would make up this plane. I'll just kind of draw it around here as best I can. Like that. Those 3 points are in a flat surface. Okay, so if you have 3 points that are not in a line, what do you have then? A flat plane. Okay, that's the 3-point postulate. Kind of like the 2-point postulate. 2-point postulate said you have 2 points, you have a line. Switch it around. You have a line, you have 2 points. Well, what if I switch this around and go to plane point postulate? Basically saying if you have a plane, then what do you have? If you have a plane, what do you have? 3 points that are, what's the word? What's the word I underlined up there? Non-collinear. If you have a plane, if I have a flat plane like this, so if you have a plane, then what do you have? You guys just told me. Then you have 3 points that would be non-collinear. Okay? Aren't these two just reversed right here? Aren't these two just reversed? Okay? Make sure you have those diagrams down. Those diagrams really do a great job of explaining what it is the postulate is saying. You're going to be asked to identify which postulate is being modeled throughout problems today. I can't stress enough how important knowing this is going to help you in the next couple of sections in Chapter 9. Okay. Take a look at your notes and compare them to mine. Are you guys with me on this? You got what you need? Any questions so far, kiddos? All right, let's roll to page 2. Hey, page 2, more postulates. I love it. Plane line postulate, plane line postulate, plane line postulate. It says if 2 points lie in a what? Plane, then the line containing them lies in a plane. Oh, okay. I'm going to divide this up again, like so. Kind of like an if-then thing. Excuse me. All right. How about a volunteer to read that plane line postulate for me? Why not, John?
Yes.
Go for it. Read that plane line postulate for me, would you, bud?
If 2 points lie in a plane, then the line containing them lies in the plane.
Okay, so 2 points lie in a plane. If 2 points lie in a plane. So here's my plane. And I'm going to tell you that point A and point B are right in there. A is here, B is down here. I have a plane, 2 points. So if those 2 points are in the plane, what must also be in that plane? What's it say here? What's it say here? A line, you bet. So if I have that plane right here with points A and B right here, then that line AB also lies in that plane. Okay? And then the last thing you have, and I'm going to have a hard time drawing this, but guys, if you have 2 planes that intersect, then their intersection is a what? 2 planes intersect, they form a what? A line. Man, I'll show you some diagrams that look pretty similar to that here, but take a look at this and this right here. Is this a plane right here? Is this a plane?
Yes.
Is this a plane? If I put them together edge to edge right here like that, where they meet, what's formed there in the corners?
A line.
It's a line. It's a line formed at the corner. So 2 planes intersect in a line. We've talked about that before, okay? We've talked about that before. All right, so here's what I need to do. I'm going to put some diagrams up here for us to kind of work off of, and I'm going to see how this goes. I'm a little concerned about it because I thought you guys had that in your big ideas, and apparently not. So I'll do my best to get these diagrams up here for you. Okay. Perfect. Okay, here's a diagram right here. I want to know which of the postulates is being illustrated in the diagram A. All right? So right here it says if, what's happening right here? What's happening right here? Two lines are crossing, right? Then, what's different about the diagram on the left and the diagram on the right? There's a point there. That's basically saying if two lines cross, they cross in a what? They cross in a what? Point. Okay? So maybe our best job here is to sketch this again. I'm going to sketch what they have up there. I'm not going to try and sketch the planes up there. I just can't. But you know what? I can do this. I can do this. I can do it. I'm going to draw A. First one. You want to draw this where part A is, you bet. I think that'd be a good idea. I think that'd be the best thing for us today.
Not in the other box.
In part A where I'm drawing, I think that would be fine. Okay? So guys, you need to go through all your postulates right there and tell me which postulate's being modeled there. Which postulate's happening there, guys? Look through your first page of postulates and then to the top of the second page. Which postulate's being modeled there in diagram A? The line intersection postulate. If two lines intersect, that's what this says. If two lines intersect, then they intersect in a point. Okay, then they intersect in a point. So, what did you say that was again, McKenna?
Line, point.
I thought you said line intersection point. Line intersection postulate. Good. Okay, line intersection postulate. That's what you need drawn for part A, right there. Okay? That's what you need to have drawn for part A. Alright? Okay. Part B then. Part B. I'll pull that diagram up here again. Part B. You know what? I'm not even going to try and draw part B. You just tell me what's happening here. What just happened now? I'll pull it up this way. Part B. Here's part B. Guys, what's happening here? If two planes cross, then what? What's different about the drawing on the left and the drawing on the right? There's a line, right? There's that red line they highlight. So this is saying if two planes cross, then they cross in a what? Line. That's all that diagram is stating. So which postulate says if two planes cross, they cross in a line? Two planes are doing what, guys? They're intersecting, right? So what postulate are you calling this? Plane intersection postulate. Not too tough, is it? Not too tough. It's the plane intersection postulate. Plane intersection postulate. Okay? Yep, you want to see the picture again? There it is. Two planes cross. I could try and draw it. You want me to try and draw it?
Yes.
You want me to tell you how to draw it? You want the shortcut on drawing it?
Yes.
Can I go to a new page and draw it? Okay, do this. If you want the drawing, here's what you're going to do. Draw a parallelogram like this to start. Draw a parallelogram like this. Got it? Got that part? Okay, now, I go back to this drawing here. You got that one? Yeah, and I'm not going to put dotted lines in here, okay? I'm going to show you what I think you should do. Okay, here's what I think you should do to draw this. Now, see this corner right here? See this corner right here? Go straight up and through it, back down a bit to this corner, maybe down this way, and back this way. Now I'm fortunate because mine I'm allowed to adjust stuff, but
Like this? What? That cannot work.
it's basically two parallelograms across each other. And here's your line that they meet at right there. This is where they kind of meet, right in there. It's goofy.
Put it like that.
Yep.
And then right here.
Yep.
Wait, they don't meet there though.
Well, you've got to draw more flat and then straight down and back up. You got a triangle there.
I don't know how you do that.
Got it? And there's the line that they meet at right there. Got it? Art aside, you just need to know that if you have two flat surfaces that cross each other, where do they cross? If you have two flat surfaces, where do they cross?
A line.
Okay. All right. Back at it then. Whoops.
What's going on over there?
Where? I don't know.
I think I'm watching a movie because it looks dark in there. Okay, you're looking at bang, bang. Go check. Open the door, check.
Okay. Example 2. I'm going to get you to example 2 here quickly, so give me a second on this. Oh, shoot. Why did I do that? That was dumb.
Whoa, put it down.
Yeah, man.
No need for violence in math. Put the hand away from me. Put the finger away from me. Can you send you a picture of flowers? Did you get one this morning with Christy? You sent me through. Last time you go down to the Fort Cobb National
All right, here we go. Example 2 that I wanted to look at, that I aligned this with today. In example 2, this is a good one. I like this. Okay. Guys, right here, here's a diagram right here. It says, use the diagram to write examples of the plane point postulate and the plane line postulate. Okay? First of all, guys, do you guys see this Q right up here? Can you see the flat surface that angles this way? Kind of the lighter of the two tans. See that flat surface that's the lighter of the two tans right there? That's plane Q. What plane is this? Plane P. Okay, plane P. We need to use the diagram to write examples of the plane point postulate and the plane line postulate. Now I'll come back to this in a second, but you guys take a look at your notes and find the plane point postulate for me, first of all. Find the plane point postulate. Okay, plane point postulate, bottom of the first page of notes, right? We need to write an example of that, plane point postulate. Somebody read that postulate to me for me.
A plane contains at least 3 non-collinear.
A plane contains at least 3 non-collinear points. Well, guys, it looks like to me the only plane they put points in is what plane? Plane P, okay? So find your plane P. Plane point postulate. A plane contains at least 3 non-collinear points. Are there 3 points that are non-collinear in plane P?
B, A, and C.
B, A, those will line up, but C, are B, A, and C in a line? No, so I can say in plane P, you have points B, A, and C. Okay? So what I might say here is this. In plane P, there exists non-collinear points B, A, and what? In plane P, there exist points B, A, and C, which are non-collinear. So I'm going to write that right here. So for my plane point postulate, which is part A, I'm going to call it the PPP. Is that okay? In the plane point postulate, which was said this, in plane P, points A, B, and C are non-collinear. In plane P, points A, B, and C are non-collinear. Okay, the second thing we needed to write for was the plane line postulate. The plane line postulate. Okay, two planes intersecting a what? Line. Two planes intersecting a line. Two planes intersecting a line. You guys have that down right there in part A? So I'm going to run through my diagram here. Here's your diagram. What are the name of the planes again? Plane Q and plane P. There's no point by it, okay? These two planes cross. Where do they cross at? Which lines do they cross? How would I name that line where they meet? What's the name of the line where they cross? They meet at line M, don't they? Okay, they meet at line M, don't they? Okay, so it says use the plane point postulate. We already did that. And then the plane line postulate. We're going to say planes Q and P intersect at line what? M. That's what that says. So I'll write that. Planes Q and P planes Q and P intersect at line M. Planes Q and P intersect at line M. Okay, planes Q and P intersect at line M. And again, here's the diagram for that. Q is here, P is here, line M. That's where they cross. Hey! Which postulate was that again? Makes sense, doesn't it? Plane line postulate. How do you get planes to form a line? Okay. All right, I'll get through example 3 and we're going to cut it off there. Example 3 is pretty easy, all right? Example 3 is going to talk about sketching a diagram. Now, guys, this didn't print out the best way I thought, but this is the best I knew how. This says ray Vx, so you might want to put a ray symbol above Vx in example 3. This is supposed to be line UW, and this is supposed to be ray Vx, line UW. Okay. Guys, sketch a diagram showing ray Vx intersecting line UW at the point V, so that Vx is, what's the word? So what angle? What angle? 90 degrees to the line UW, and UV and W are collinear. Well, the first thing you know is you have a line, don't you guys? Okay, we've got a line. So I'm going to go ahead and draw my line. Let's get a line here. And let's call this line, what's the name of the line, kiddos? What's the name of the line? U to W, right? Okay, we've got that line UW, right? Now, there's a ray that intersects this. It says there's a ray that's intersecting this line at what point? At what point? At V, and is, okay, can I go off at an angle from this line, like this, or do I have to go straight up and down? What do you need to do? Perpendicular, what angle? Up and down, 90 degrees, okay? Okay, so you're going to have a ray that looks like this. Good, Taryn. Maybe I put it, I don't know, it doesn't really matter where I put it, but I put it right here. Now, guys, the way it's drawn right there, do I know if these lines are perpendicular? The way it's drawn right here, do I know these lines are perpendicular? I don't. So what did I better put in between that line and ray to indicate that they are perpendicular? 90-degree symbol, okay? And we're calling this ray V what? So V has to be right here. So the ray and the line intersect at V. Here is X. So we've taken something in words and we've drawn a diagram. Are U, V, and W collinear like they want it to be? Are U, V, and W collinear? They are, aren't they? Okay. So I'm going to stop there. Guys, I want to do something today. On your notes, I just want you to flip your notes to the front page, and I want you to put your name on your notes, and I'm going to collect them quick. So, Tara, will you run around and get the notes for me?